From everyday activities like throwing a ball around to how the planets move, kinematics is involved with all of it. In this video, we'll cover the basics, including displacement, velocity, and acceleration, to help you understand the science behind motion. In this video, I'm just talking about what displacement, velocity, and acceleration are, not how to calculate them. If you want to learn how to calculate these things, watch my other video on how to solve kinematic equations using the Big Five. So I'm first going to be talking about distance versus displacement. Distance is described as the space traveled during a set period of time, while displacement, on the other hand, is the space between your start and end position. These both use units that describe 1D space. For example, meters, centimeters, miles, kilometers, etc. Another difference between the two is that displacement has a direction. For example, if you drive your car 5 meters west, then your distance would be 5 meters, and your displacement would also be 5 meters, but it would be 5 meters west. If you then turn around and drove back 2 meters east, then your total distance would be 7 meters because you traveled 5 meters and then another 2 meters, so they add up to 7. Your displacement would only be 3 meters west because you are 3 meters west away from your start position. To learn more about displacement, watch my video called Displacement Explained Simply. Velocity. Velocity is described as how much your displacement will change during a certain period of time. One way to think of it is that it's just speed with a direction. It's measured with meters a second, kilometers an hour, any distance unit divided by a time unit. It also has a direction, whatever direction the object is going in. For example, if the car from before had a velocity of 2 meters a second west for the entire trip on the way up, that means that after 1 second, the car will have traveled 2 meters west. After another second, it will have traveled 4 meters west, because 1 times 2 equals 2, and 2 times 2 equals 4. Quick question. If the car continues to travel at 2 meters a second west, how long would it take to travel the last 1 meter? It would only take half a second. Acceleration. Acceleration is described as the rate at which your velocity changes at a certain period of time. It is typically measured in meters a second squared. It also has a direction. Imagine the car is starting from rest and accelerating at 2 meters a second squared west. This means that after 1 second, the velocity of the car would be 2 meters a second west. After 2 seconds, the velocity would be 4 meters a second west. Your car's velocity will slowly increase and increase and increase, which means you'll be able to go further and further distances in the same amount of time. For example, after 10 seconds, its velocity would be 20 meters a second, which means it can now travel 20 meters in just 1 second. Because velocity is changing the whole time, it gets harder to calculate displacement while the car is accelerating because it's not as simple as just multiplying the time by velocity like I did before. Now you would have to use kinematic equations called the Big Five to calculate more complex problems with acceleration in them. I have a whole video called How to Solve Kinematic Equations Using the Big Five that you could watch if you're interested. I also have another video that explains velocity and acceleration more in depth. Please leave a comment if you have any questions.